Hi everyone, today we're going to talk about polar coordinate system. Let's have a short review of a rectangular or Cartesian coordinate system. The rectangular coordinate system consists of two real number lines. The horizontal number line is called the x-axis and the vertical number line is called the y-axis. The point of intersection of these two lines is called the origin. Each point on this plane is associated with an ordered pair. Say point A is associated with an ordered pair 3, 2, where 3 is the x-coordinate and 2 is the y-coordinate. In a polar coordinate system, we select a point called the pole. Note that the origin in rectangular coordinates coincides with the pole in polar coordinates, and the positive x-axis in rectangular coordinates coincides with the polar axis in polar coordinates. Each point in a polar coordinate system is associated with an ordered pair r, theta, in which r is the distance of the point from the pole and theta is an angle formed by the polar axis to this ray. Identify the polar coordinates of the point. Point P has polar coordinates 5, 45 degrees. The 5 is the distance of the point from the pole and the 45 degrees is the angle formed by the polar axis to this ray. A point in rectangular system is associated with a unique ordered pairs, but in polar coordinate system, a point is associated with an infinitely many polar coordinates. Take example A. This point has polar coordinates 5, 45 degrees. Now that same point, as we see in example B, can also be represented by polar coordinates 5, negative 315 degrees. Letter C. The point has polar coordinates 5, negative 135. If I flip this point, or if I draw a ray that is directly opposite this given ray, then the 5 turns to negative. So it's negative 5 and the angle stays the same. It's still negative 135 degrees. So a negative r, so in this case, a negative 5 indicates opposite direction. So in letter D, this given point here has polar coordinates 5 and 225 degree angle. So if I flip this point or draw a ray that is directly opposite this given ray, then this 5 here turns to negative 5. Again, the angle stays the same, 225 degrees. Let's see another example. Write the polar coordinates of the given point in 3 more ways. This given point here has polar coordinates 2. That's the r, the distance of the point from the pole, and the angle theta of pi over 2. We can represent that same point using a negative angle. That is, the r is still 2, but the angle is now negative 3 pi over 2. Another way to represent that same point is to consider this point down here, say point B. Its polar coordinates are 2 with a negative pi over 2 angle. What happens if I flip this point? If I flip point B, I'll get point A, which is directly above point B. And the polar coordinates of A are going to be, since it's opposite direction, I'm going to negate the r. So it's now negative 2, negative pi over 2. Note that the angle stays the same. Let's look at another way to name that same point. I will consider this point down here again, say point B, and the polar coordinates are going to be 2, but I can use this positive angle for our theta. So that's 3 pi over 2. Again, I'm going to flip this point in order to get point A. Since there's like a reflection involved or flipping involved, I need to negate the r. So the 2 becomes negative 2 and the angle stays the same. Let's see the last set of examples. Plot the following polar points. Point A with coordinates 3, 5 pi over 6. In plotting a polar point, you always start with the angle. Here, the angle is 5 pi over 6. So let's find the angle 5 pi over 6. So this is the angle 5 pi over 6. I'm using concentric circles to assist me to plot the point. Now find the point that is 3 units from the pole. So this point is 3 units from the pole. So this is the polar point A. Next, plot the point B with coordinates 2, negative pi over 6. Let's try to plot point B without the concentric circles. So again, let's start with the angle negative pi over 6. So negative pi over 6, go clockwise. So this is our negative pi over 6. Then, find the point that is 2 units away from the pole. So this is the point whose distance from the pole is 2 units. So this is our polar point B. Let's see the last example. How do you plot a polar point with a negative r? First thing we need to do is plot a point in which the r is positive. So in this case, we plot positive 4, 120 degrees. And let's name this point D. After we plot point D, flip it in order to plot point C. So the flipping turns the positive 4 into a negative 4. So let's go ahead and plot point D. Begin with the angle 120 degrees. So this is the 120 degree angle. And then find the point that is 4 units away from the pole. 1, 2, 3, 4. So this is the point whose distance from the pole is 4 units. Its coordinates are 4, 120 degrees. Now once we flip this point, we're going to get point C, which is directly opposite point D. So this is our point C with polar coordinates negative 4, 120 degrees. Note that the angle stays the same, but the r, which is 4, turns into a negative 4 because of the flipping or the reflecting that we did.
Thanks everyone. Please don't forget to subscribe. That really means a lot.